Okay, on this video, I'm going to go through the solutions here for the review from lessons 5.1 to 5.3, and they're part of 6.1. The first one here was basically just a calculator problem. You had to convert 84.888 degrees to degrees, minutes, and seconds. So what we're going to do is we're going to use the angle menu to convert this. So the angle menu is above your apps button. So I'm going to hit second and then apps. And I'm going to convert it to degrees, minutes, and seconds. So that's just the fourth choice there. So you just hit 4 to choose that one. And so now that's going to convert that from degrees into degrees, minutes, and seconds. So that would be 84 degrees, 53 minutes, and 16.8 seconds. Now, so that was the answer to number 1 there. Now, number 2, we're sort of going the other way around. So number 2, let me clear out what I got. We're going to change 52 degrees, 18 minutes, and 24 seconds to just degrees. And we're probably going to round it here off because I'm probably going to have a decimal. Now, so what we have to do is we have to punch in 52 degrees, 18 minutes, and 24 seconds here. So I'm going to punch 52, and then I'm going to go to the angle menu and get my degree symbol. And then 18 minutes, so I'll punch in 18, go back to the angle menu, and you see the second choice there is minutes. And for seconds, the seconds, unfortunately, is not in the angle menu where it should be, but it's above the plus sign. In most calculators, it's in green, so you have to hit alpha and then the plus sign. So now that's 52 degrees, 18 minutes, 24 seconds, and all I have to do here is hit equals, and it will give me the decimal value for that. So the direction said rounding to the nearest thousandths. So to the nearest thousandths here, that would be 52.30, and it would round up to 7. So my answer there would be 52.307 degrees. I really need to put my degree symbol in there so someone doesn't read it as a radian measure. Okay, now let's look at the other ones. All right, number 4 asks you to take these 4 angles here and to find a coterminal angle that would be in between 0 and 360. So there's lots of reasons that we've seen here that we want angles to lie in between these. Number 1, we can find out what quadrant they would lie in to find such things as like reference angles. The other thing is we might want to locate a certain angle on the unit circle. And so we can only do that if the angle falls in between 0 and 360 degrees, or in terms of radians, it would be 0 and 2 pi. And so all I really have to do here is, if my angle doesn't fall in between those measures, is we can find a coterminal angle by just repeatedly subtracting or adding 360, or subtracting or adding 2 pi. So on A, 800 degrees, okay, let's kind of note this one. I'm not going to go through the process on the other ones. But if I was going to go 800 degrees here, if I went all the way around one time, that would be 360 degrees. If I went all the way around 2 times, then that would be 720. And so I would need 80 more right here to get to where the angle would actually be. So this standard position angle right there would measure 800 degrees, or we could just say 80 degrees. 80 degrees would fall in between 0 and 360. Now, the simpler way of doing this, besides drawing it, is like I just said, either subtract 360 multiple times and sort of take this idea and unwind it, okay, or add 360 multiple times if it's negative. So really what I'm going to do is just take my calculator and punch in 800 minus 360, and if I do it once, that still doesn't lie in between 0 and 360. I get 440. So I'm going to subtract 360 again, and then we get 80. So 80 degrees, see, I found it both ways there, is my coterminal angle for 800 degrees. So they're the same location as far as standard position is concerned. 800 degrees just had to go around the unit circle twice. All right, on B, we've got negative 800 degrees. So visually what we would do there is, since it was negative, it would go clockwise, and it would have to go around 2 times here and then go 80 degrees down this way. Okay, so again, all we can really do to make that simpler and faster is just to add 360 multiple times. So my calculator, I'm going to put in negative 800 plus 360, and that gives me negative 440. So I have to do it again. Negative 440 plus 360 is negative 80, so it's still negative. So I'm going to add another 360, and then finally it's positive. And so we get that it's about 280 degrees. Now on C and D, we're going to note both of these are in terms of radians, and they're in radians not because you see the pi symbol, but because there's no degree symbol. That means that they're in radians. So 25 pi over 12, let's note if I go around the unit circle completely that it's 2 pi. So 25 pi over 12 would be a little bit more than 1 revolution. So instead of subtracting 360 because it's too big, we're going to subtract 2 pi. Now really what we're going to do in our calculator here is we're just going to take 25 over 12 without the pi sign and just subtract 2. That way if I push the pi sign, I get a bunch of decimals. So if I just type in 25 over 12 on my calculator minus 2, I'm going to get this is 1/12. So the coterminal angle here for 25 pi over 12 would not be 1/12, but it would be like 1 pi over 12, or just pi over 12. Now, for part D, now this one's negative, so the only difference here is I'm going to add 2 pi. Now really what I'm going to do is just take negative 25 over 12 and add 2. I might have to do it a couple of times. Let's see, negative 25 over 12 plus 2 is negative 1/12. So notice I'm going to have to do this one more time because it's still negative. So plus another 2. And so let's see, that's going to give me 23 over 12. So my coterminal angle, in other words, the same angle here, is going to be 23 pi over 12. So it's a matter of adding or subtracting 360, or adding and subtracting 2 pi to find the coterminal angle. Now, the next ones here ask for reference angles. And so let's look at the definition of a reference angle really quick first. The reference angle is the acute angle that's going to be formed by the x-axis. Okay, and we said in degrees here that instead of drawing these out every time, that we developed rules for each quadrant. So we're going to recall the rules for each quadrant real fast here. So in the first quadrant, the angle that's going to be formed with the x-axis is always just going to be the same angle. So in the first quadrant, the reference angle is the same as the coterminal angle. Now, in the second quadrant, notice the acute angle formed by the x-axis here is going to be this angle. Okay, notice it couldn't be this one because that would be formed with the y-axis, and I couldn't form it with the x-axis here because that wouldn't be acute. So let's think in terms of degrees here. We were trying to find the reference angle. If I went all the way around to this point, that would be 180 degrees. So I'm going to take whatever the angle is right here and subtract it from 180. So it'd be 180 minus the angle. Now, so that's in the second quadrant. In the third quadrant, notice the reference angle would be formed again with the x-axis with that acute angle right there. And so notice to find it, it would be more, just a little bit more than 180 right there. So I could take that angle and just subtract 180 from it, and then that will give me the reference angle. And now, finally, for the fourth quadrant, notice the acute angle would form this way. And so if I went from standard position all the way around to there and went all the way, that would be 360. So really what I'm going to do is just take 360 and subtract the angle to find it if it's in the fourth quadrant. Now, you could always draw these angles and figure them out. And I was more of a figure out person when I was your age, and I didn't really memorize too well. And so I always drew the angle and just figured out what the reference angle was. Now, let's go through these. I'm really not going to draw, I might draw one of these for you here, but really what I'm going to do is apply the rules here as to what quadrant it's in. Now, when it's in radians, that's going to be a different story. Now, notice A here is really the hardest one because 584 degrees doesn't fall in between 0 and 360, and I need to know what quadrant that it's going to be in. So what I'm going to do first is not find the reference angle, but I'm going to find the coterminal angle like I did in the last problem there and subtract 360. So when I subtract 360 from this, I get 224 degrees. So 224 degrees would be in the third quadrant. So remember our rules here. If it's in the third quadrant, all I have to do is take the angle and subtract 180. So 224 minus 180 is 44. So my reference angle is 44 degrees there. So don't misunderstand, 224 is not the reference angle. That's the coterminal angle that I can find on my unit circle here that lies in between 0 and 360. Okay, on part B, we're 350 degrees, which would be in the fourth quadrant. And so if it's in the fourth quadrant, we said we're just going to take 360 and subtract 350 there. So that's going to give me 10 degrees. Okay, on part C, we've got 400 degrees. Now 400 degrees, that's one that's kind of too big here, so I'm going to subtract 360 from it. So let's see, 400 minus 360 would be 40. Now 40 is in the first quadrant, and if it's in the first quadrant, the angle is the reference angle. So it's the same measure. Now on part D, we'll draw this one. We're doing 107 degrees, so that's 90, that's 180. This is how we could draw it here. This is 270. And then we started at 0 and went all the way around to 360. So 107 would be just past 90 right there. So we're looking for this reference angle right there. And so if we picture it here, all the way to here is 180. So we're just going to say 180 there minus the 107. I'm just going to type it in my calculator here. 180 minus 107 is going to be 73. So my reference angle there is 73 degrees. Now, when we get down to the other four, these are a little bit more difficult because they're in radians. Usually, if they're in degrees, we can really just figure out, especially if it lies in between 0 and 360, we can figure out what quadrant that it's in. However, so if it's in radians, we really probably don't think as well in terms of radians because we haven't dealt with them that much. So I've set up these four problems so that they have the same denominator. So hopefully you figured out that you could just draw just one graph for them. Okay, so I'll think of my angles now being radians. So instead of 90 degrees right there and 180 right here, in terms of radians, we said that this was just pi halfway around. All the way around is 2 pi. And so halfway to pi is pi over 2. And then 3/4 of the, or excuse me, if I go to pi and then another halfway, it's going to be 3 pi over 2. Now, so let's start off, and I'm going to kind of color code them here. So we'll make this one black, this one red, this one green, and this one blue, because I can do that. All right, so the red one there is pi over 5. So now all of them are over 5. So let's switch these in terms of 5s here. So instead of pi, I'm going to think of it as 5 pi over 5, because that would be the same thing as pi. And so halfway to 5 pi over 5 would be 2.5 pi over 5. So notice every 90 degrees is 2.5 pi over 5. And so if I go 2.5 pi over 5 more here, that would be 7.5 pi over 5. And then all the way around to get 2 pi would be 10 pi over 5. Okay, so now let's imagine here, where would pi over 5 be? So this was 2.5 pi over 5. So that's going to fall in the first quadrant. Okay, so somewhere right along in there. Now, the question is, well, what's the reference angle? Well, if it's in the first quadrant, then it's pretty simple. The reference angle is just the same as the standard position angle. It's just pi over 5. Now, let's look at F, which is 3 pi over 5. So notice again, this was 2.5 pi over 5. So this is going to be a little bit past right there. It's going to be 3 pi over 5. So now the reference angle is the angle formed, the acute angle formed with the x-axis, which would be this much. So if I'm going from 3 pi over 5 to 5 pi over 5, then I'm going a 2 pi over 5 angle. So 2 pi over 5 is my reference angle. Okay, now on G, we're at 6 pi over 5. So notice there's 5 pi over 5. So 6 pi over 5 would just be past there. And so the reference angle, again, the angle formed with the x-axis would be there. And so we're looking for just this much. Now, all the way, let's see if I can picture it here. All the way around here is 5 pi, and then we're going to 6 pi. So from 5 pi to 6 pi over 5, we're going a pi over 5 to get there. So my reference angle there is pi over 5. Okay, now on H, we're doing 8 pi over 5. So notice this is 7.5 pi over 5. So 8 pi would be just past there. And so the way I'm going to do this one is kind of see, well, again, the reference angle is going to be formed with the x-axis. Is what's this angle now? If I go from 8 pi to 10, 8 pi over 5 to 10 pi over 5, well, that would be 2 pi over 5. So my reference angle there is 2 pi over 5. Okay, so certainly when you deal with radian measure, it's probably a good idea to draw the angles to figure them out. And the key is to making pi and pi over 2 and 3 pi over 2 and 2 pi in terms of whatever the denominator is in your fraction. All right, on 6, you had 2 triangles here where you had to, I think you had to name the 6 ratios for. Yeah, let me do this real quick. I love the paste function here. Okay, now let's fill these in. Now let's go over our ratios here. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So notice in both triangles we have a side missing that we're going to need to find with our Pythagorean theorem. So what's missing in A is the leg. So I'm going to call that leg A. So we say A squared plus 5 squared, which would be 25, equals 10 squared, which would be 100. Now let's solve for A here. So A squared would be equal to 100 minus 25 would be 75. And then we're going to take the square root. Now 75 will simplify. I can say 25 times 3 there. So we're going to get this missing leg to be 5 square roots of 3. Okay, now let's start finding our ratios. All right, so sine is opposite over hypotenuse here. So let me do this so I can point better. So this is from the angle theta right there. Opposite would be 5, and then the hypotenuse is 10, because the hypotenuse is always across from the right angle. So 5/10 for the sine, and probably most of you just probably already know that that would reduce to a half. All right, now cosine, from the angle, cosine is adjacent over hypotenuse. So adjacent, there's 5 square roots of 3 over the hypotenuse 10. So 5 square roots of 3 over 10, which would reduce to the square root of 3 over 2. And now the tangent for my angle theta there is opposite over adjacent. So that would be 5 over 5 square roots of 3. Those 5s are going to cancel out, so I'm going to get 1 over the square root of 3. I would need to rationalize here, so that would rationalize to the square root of 3 over 3. Now, for my other 3, or the last 3 here, we're just going to, if I can get it selected, nope, I can't, do the reciprocals. So cosecant is the reciprocal for sine. So since sine was 1/2, then cosecant is just going to be 2. And since cosine was square root of 3 over 2, secant would be 2 over square root of 3. Now, to put that, though, we're going to have to rationalize. Okay, so that would give me 2 square roots of 3 over 3 if we rationalized it. And now cotangent is going to be the reciprocal for tangent. So let's recall here the tangent was square root of 3 over 3. Now I'm going to use this one to take the reciprocal of. That way I don't have to rationalize it. So if I just take the reciprocal here, I'm going to get square root of 3 over 1, which is just square root of 3. Stop writing there for a minute. Okay, now my other triangle, so for triangle B over here, we've got 3 and 7. Let me try to copy this real quick. Let me just put it on another page. Okay. So this time here, what's missing is my hypotenuse before I can find my ratios here. So since the hypotenuse is missing in my a squared plus b squared plus c squared, the c squared is what I'm looking for. So 3 squared would be 9, 7 squared would be 49, and then 49 and 9 here would give me the c squared. 49 and 9 is 58. And so when I take the square root of that, I don't believe that's going to simplify to anything. I don't think 58 divided by 4. I know it doesn't divide by 9 or 16. So I don't believe that simplifies. So we're just going to leave it as the square root of 58. Okay, now let's find our ratio. So from theta, so notice theta is in sort of a different position now. It's sort of in the top part of the angle. So let's see, sine is opposite over hypotenuse. So that would be 7 over the square root of 58. Of course, we'd have to rationalize that. So it would be 7 square root of 58 over 58. Cosine from my angle here is adjacent over hypotenuse. So that would be 3 over square root of 58, which would rationalize to 3 square roots of 58 over 58. And now tangent is opposite over adjacent. So opposite is 7, adjacent is 3, so that would be 7 over 3. Now my other ones we're just going to find by doing reciprocals. So it's called cosecant is the reciprocal for sine. Now instead of taking the reciprocal here, let's take the reciprocal here. That way we don't have to rationalize it. So it would just be square root of 58 over 7. And so the same thing for secant. Secant is the reciprocal for cosine. So there's cosine, but again, let's take the reciprocal here because it's much easier. So that would just be square root of 58 over 3. And then cotangent is the reciprocal for tangent. So we're just going to do the reciprocal of 7/3, which would be 3/7. Well, that was boring. All right. Now let's do these. These are kind of fun. Now they're pretty easy here as long as we know how to use the unit circle. So it says evaluate the following by using reference angles or the unit circle. So I really didn't show you guys how to do these by reference angles. I just basically showed you on the unit circle how to do these. So you really need a unit circle, your unit circle in front of you. That's why it's kind of important to learn the unit circle so you can really do these problems in the future like this. And look what we have there. We have a unit circle ready for me here. So we're going to look for, well, let's go over this first. On my unit circle, all right, let's recall that the cosine is the x-coordinate of a certain point. So like randomly here at 150 degrees, the cosine would be square root of 3 over 2. And then if we were doing the sine would be the y-coordinate. So at 150 degrees, the sine is 1/2. So cosine is x, sine is y. So for secant and cosecant, we could just use sine and cosine by using the reciprocal identities. Now for tangent and cotangent, recall that tangent here, tangent of an angle theta, is the sine of the angle over the cosine of the angle. And so cotangent here would just be the reciprocal, which would be cosine theta over sine theta. Now let's go through and answer these questions now. So with my unit circle here, first one, the sine of 90, kind of cut off right there, but that point is 0, 1. So the sine there is the y-coordinate. So the y-coordinate there is definitely 1, so the sine of 90 is 1. Now the cosine of 315 degrees, so let's go to 315 down there. So the cosine is the x-coordinate, which would be right there, the square root of 2 over 2. All right, part C, the tangent of 315 degrees. So now on 315 degrees, again, the tangent is the sine over the cosine. So it would be this negative square root of 2 over 2 divided by square root of 2 over 2. Now, since they're the same numbers, they would just cancel out. Now, the negative sign would still be there, so that would just leave me with -1. So we've mentioned usually the midpoint of each quadrant right there, that both the sine and the cosine were just a version of square root of 2 over 2. So the answers there for the tangent of the cotangent would either be 1 or -1 because they were the same numbers, just sometimes negative. All right, on part D, you have the cosecant of 150 degrees. So what we're going to do for that is at 150 degrees here, we're going to look at the sine. And so the sine, the y-coordinate, is 1/2. Now that would be the sine. So the cosecant would be the reciprocal of that, which would just be 2. Okay, let's look at the next 4 now. Hold on down here, unit circle. Okay, so now secant of 210, so there's 210 degrees. Now, so for secant, what I'm going to do is look at the cosine. The cosine, or the x-coordinate, is negative square root of 3 over 2. So that would be the cosine of 210. So the secant would just be the reciprocal, which would be -2 over square root of 3, which I'd have to rationalize. So it would be -2 square root of 3 over 3. Now the cotangent of 120 degrees, let me find you 120 degrees. There you are. Okay, so cotangent is the cosine over the sine. So we're going to do 1/2 divided, or -1/2, divided by the square root of 3 over 2. So this is going to take some calculation here. Let's do -1/2 over the square root of 3 over 2. So this would be the same thing as saying 1/2 times the reciprocal there, which would be 2 over square root of 3. So the 2's would cancel. So I'll get 1 over square root of 3, which would rationalize to square root of 3 over 3. There again, Tangents and cotangents could be found faster if you do a little bit of memorizing. So if you will memorize here that the tangent of pi over 6, or 30 degrees, is square root of 3 over 3, and the tangent at pi over 3 is square root of 3, all you have to do is reflect those over. Now I'll call those are the tangents. So over here, the tangent would just be negative square root of 3. I missed my negative. See, I'm glad I did this because I missed my negative sign. It's going to be negative there. And so this is going to be negative square root of 3. Now that would be the tangent. And so the cotangent is what I've got right there, the reciprocal there, negative 1 over square root of 3. So it's really, really valuable here if you will memorize the tangents for both 30 degrees and 60 degrees. And if you memorize them, then you don't have to figure them out anymore. Now, that's just sort of optional if you don't memorize. All right, letter G, cosine of 0 there. So at 0, the cosine is the x-coordinate, which is just 1 there. Let's keep going. Let's go down to H. So now we're looking at the tangent of 270 degrees. There's my 270. We're at 0, 1. So recall, tangent is sine over cosine. So sine is 1, cosine is 0, and we get 1 over 0. We can't divide by 0, so that's one that's undefined there. Right, the sine of pi over 6, that's pretty easy. Now they're switching to radians. It's no big deal. Here's pi over 6 in radians. It's the same thing as 30 degrees. The sine is the y-coordinate, so that's just a half. Right, on J, 840. Now, look at 840, and I said, well, 840 is not on the unit circle. So what do I do? Well, I guess I'll just miss it. No, I can't do that. I'm the teacher. So we got to find a coterminal angle is the idea. So if I find a coterminal angle that lies in between 0 and 360, we can do that. So I'm on 840 on my calculator, and I'll probably subtract 360 a couple times. If I do one time, I get 480. If I do it 2 times, I get 120, and now I can do it. So let's see, the cosine of 120 degrees here. There's 120. Cosine is the x-coordinate, so that's just negative 1/2. Okay, and now on K, we got 25 pi over 12, so I don't see 25 pi over 12, and I don't think this one's on our unit circle. Probably should have omitted this one. Yeah. Let's see. Yeah, we're going to omit K there, so don't worry about it. That's not on the unit circle, so I wouldn't expect you to know that one yet. We'll learn how to do that one by summing difference later. Okay, now the sine of negative pi over 6. Now that happens to be negative, so we could add 2 pi. If you added 2 pi to that, that's going to give you, I think, 11 pi over 6 would be the coterminal angle. So you would be at 11 pi over 6. Now, one way to look at it is think about it this way. Pi over 6, just pi over 6, goes counterclockwise that way. So negative pi over 6 would just go down to here. So the sign there is that y-coordinate. So that's going to be negative 1/2. Okay, number 8, we're given basically an ordered pair, and we have to fill in all 6 ratios for that ordered pair. So there are things you can memorize here to get the ratios for the ordered pair. But instead of trying to memorize a bunch of ratios here, we can do all this from just drawing a simple triangle. So we'll draw the triangle here for letter A here. So negative 5, 6, either negative 5 and then 6 would be somewhere right there. So the angle would go through that point and terminate at that point. Now, we have to find the ratios for the angle theta there. So what we're going to do is we're going to form a triangle with the x-axis. You always form it with the x-axis, so it's going to go downwards. Form with the x-axis. And theta is always at the origin. And so now, if this is the point negative 5, 6 here, that means I went negative 5 or 5 to the left and then up 6. Now I have to find my hypotenuse. That's not going to be hard. we're going to say a squared plus b squared equals c squared. So 36 plus 25 equals c squared. 36 and 25 here, I think, is 51. Wait a minute, 61. And that's not going to simplify to anything here, so it's just going to be square root of 61. So now from theta, all I have to do is look at my triangle and name them. So from theta there, the sine is opposite over hypotenuse. So it would be 6 over the square root of 61, which would rationalize to 6 square roots of 61 over 61. Cosine is adjacent over hypotenuse, so that would be negative 5 over square root of 61, which would rationalize to negative 5 square root of 61 over 61. And then the tangent is opposite over adjacent, so that would just be 6 over negative 5, so negative 6/5. Now, for my other three, we're just going to look at the reciprocal. So for cosecant, I'm going to look at sine, and I'm going to take the reciprocal, not that one, because I'd have to rationalize. Well, I'm going to have to rationalize either way. Oh, no, I'm not. I'm sorry. So if I take my reciprocal of sine here, the square root is going to be on the top. So I'm going to do that one. It would be square root of 61 over 6. And then secant is going to be the reciprocal for my cosine right there. And so I'm at negative square root of 61 over 5. And then cotangent is the reciprocal of tangent. So it's just going to be negative 5 over 6. Now, for part B, we've got the ordered pair 5, negative 12. We'll erase my triangle in the middle here. All right, so 5, negative 12. Let's go where that one would be. So I'd go 5 this way, and I'm not going to count all the way down, but negative 12 down that way. So that's going to put it in the fourth quadrant. So we'll form our right angle here. And this one's going to work out a little bit better here because this is a nice triple. So we'd say we go to the right 5 and then down 12. So that makes it negative 12 there. And so now we can use my Pythagorean theorem to find the hypotenuse. So 5 squared, 25 plus 12 squared, which is 144, c squared. So that's going to give me 169. And this works out pretty good to give me a nice number like 13. Okay. Now, so from our angle theta here, which is formed at the origin, the sine would be the opposite over the hypotenuse. So that would be negative 12 over 13. Cosine is adjacent over hypotenuse, so 5 over 13. Tangent of theta is opposite over adjacent, so that would be negative 12 over 5. And now for cosecant, cosecant is going to be the reciprocal of sine, which would just be negative 13 over 12. And then secant would be the reciprocal for cosine, which is 13 over 5. And cotangent is the reciprocal for tangent, so it would be negative 5 over 12. Okay. And let's notice here how we can really check our signs to be sure that we're correct on each one. We can use a little mnemonic here. All seniors take calculus. And so in the fourth quadrant, cosine should be positive. And if cosine is positive, secant is positive. So we got cosine and secant are both positive like they should be. And the other four are, sure enough, they're negative like they're supposed to be. Darn, I was hoping there wasn't a C. All right, on C, let's draw this one out. So we're going to negative 3. So negative 3 and then negative 6, way down there somewhere. So negative 3, negative 6 is going to be somewhere in the third quadrant. Let me draw my triangle now and form a right angle with the x-axis and the theta angle with the origin. Now, so to get to that point there, negative 3, negative 6, we go left 3 and then down 6. So sine of theta, sine is opposite over hypotenuse. I guess I need to find the hypotenuse. So let's see the Pythagorean theorem. 3 squared would be 9, plus 6 squared would be 36, equals my hypotenuse, c squared. So that'll give me 45 equals c squared. And I think, and we'll take the square root, we can simplify here by saying 9 times 5. So it would be 3 square roots of 5 for the hypotenuse. Okay, now let's find our ratios. So sine is opposite over hypotenuse. That would be -6, that's opposite, over the hypotenuse, 3 square roots of 5. Okay, notice that's going to reduce to just -2 over the square root of 5, and I'd have to rationalize here. It would be -2 square roots of 5 over 5. Okay, the cosine is the adjacent side over the hypotenuse, so that would be -3 over 3 square roots of 5. Notice the 3's would just cancel. It would leave me with -1 over square root of 5. And we'd rationalize and get negative square root of 5 over 5. Okay, tangent is opposite over adjacent, so that would be -6. That's the opposite over the adjacent, -3. -6 over -3 would be +2. All right, cosecant. Now I'm just going to look at reciprocals. And I'm going to look at the best one, which is going to be this one, to find the reciprocal here. So that would be negative square root of 5 over 2. Secant, I'm going to look at the reciprocal of cosine, which would just be negative square root of 5. And cotangent, the reciprocal of tangent. So the reciprocal of 2 would be 1/2. Okay, number 9, really similar to number 8 there. We're given one ratio in the quadrant that it's in, and we have to name the remaining 5. So we're given 1, and we have to find the other 5. Now, one of them should be obvious from reciprocals. So if I'm given cosine there is -1/5, then the secant is going to be -5. Okay, now the rest of them I'm going to have to figure out. And the way I'm going to figure them out is to draw a triangle and use my ratio to label that triangle. So notice it says it's in the second quadrant. Okay, let's form the angle with the x-axis and theta with the origin. And now let's use that -1/5 on my triangle. So recall here that cosine is opposite over hypotenuse. So opposite of theta is going to be 1. Think about that. Dang it, I'm putting it in the wrong spot. I said that wrong, I apologize. Let me start over. Cosine, I said opposite over hypotenuse. Cosine is adjacent over hypotenuse. I know it didn't make sense for that to be -1. So adjacent would be -1, and then my hypotenuse is going to be 5. So it makes sense that's -1 because it's going to the left right there. Now we have to find our other leg to find the other 4 ratios there. So we'll say -1 squared, which would be 1, plus the unknown leg squared, so I'll call it b squared, equals the hypotenuse squared. 5 squared would be 25. So now we're going to get b squared equals 24. Let's take the square root. 24, I could break it down with 4 times 6. So that'll be plus or minus 2 square roots of 6. So we need to decide here, would this be a positive 2 square roots of 6 or negative? It's going to be positive because it's going up. Now, let's find these rest over ratios. All right, so sine is opposite over hypotenuse. So that would be 2 square root of 6 over 5. Okay, tangent is opposite over adjacent. So that would be 2 square roots of 6 over -1, which would just be -2 square root of 6. So cosecant is going to be the reciprocal for sine. So this is going to require a little bit of work here. I'll draw this one down here. So the reciprocal of sine, there was sine, so that's going to be 5 over 2 square roots of 6, which I'll need to rationalize. Having that 2 there kind of makes that difficult. So we'll slow down a little bit. I'm going to multiply by square root of 6 over square root of 6. Notice I didn't need the 2 to rationalize with. So now that would give me 5 square roots of 6 in the numerator. Now in the denominator, I'm going to say the square root of 6 times the square root of 6 would be 6. And then times that 2 would make that 12. Okay, cotangent is just going to be the reciprocal for tangent. So recall tangent there was -2 square roots of 6. So it's going to be 1 over -2 square root of 6. So I'm going to need to rationalize it. Kind of the same way I did the last one here. So I'm going to get square root of 6 over, and it's going to be the same thing we got the last time, 12, except there's negative because we got the negative over 2. Okay, now number 10. Oh, we didn't even do part B. Okay. All right, we got 5, -12 on this one. Wait a minute. I'm looking at the wrong one. Okay, we got tangent of theta is -3 over 2, and we're in quadrant 4. Let's draw our angle in quadrant 4, form a right angle with the x-axis and theta with the origin. Now, if they give me tangent is -3/2, then we should know that cotangent is going to be -2/3. Okay, now let's label our triangle here. So the tangent is opposite over adjacent. So we'll say opposite 3 and then adjacent 2. And notice that I didn't put a sign on either of them, because what I have to do is I have to figure out that that negative sign is going to be either one or the other, okay, but not both. If it was both, it would be positive. Now, so we've got a 3 here and a 2 here. So notice that's right 2, but down 3. So the negative would go on the 3. Now let's find our hypotenuse there. So we say 2 squared would be 4 plus 3 squared 9 equals c squared. So we'll get 13 there. And we'll take the square root, and that's not going to simplify. So my hypotenuse is going to be square root of 13. Now let's fill in my leftover ratios here. So sine of theta, that's opposite over hypotenuse. So that would be -3 over square root of 13. Which if I rationalize here would be negative square root, I can't say it, -3 square root of 13 over 13. All right, cosine of theta is adjacent over hypotenuse. So that would be 2 over square root of 13, which would rationalize to 2 square root of 13 over 13. And now cosecant, all I have to do is take the reciprocal of sine. Now I'm going to take the reciprocal here, though. It's going to be a lot easier, and I won't have to rationalize. So it would be square root of 13 over 3, and it would be negative. Secant is just the reciprocal for cosine, so we'll take the reciprocal here and just say square root of 13 over 2. Okay, number 10 now, finally. Okay, we're taking two angles here that are in degrees, and we're going to convert them into radians. And notice that we're going to leave them in terms of pi, so we're going to leave the pi on the answer for that. Now, the one conversion here that we're going to have to remember is this idea that pi radians is equivalent to 180 degrees. So let's set up a little dimensional analysis here. Start off with 15 degrees. And now we're going to have to put this conversion factor in my little dimensional analysis, and 180 degrees has to go on the bottom because we want those units to cancel out. So pi radians would go on the top here. So now we're just going to multiply this out. And so this is going to give me 15 pi over 180. And now all I have to do is reduce. And I think that 15 reduces out pretty good here. You could reduce by 5 first. Then I think you'd have to reduce out by 3 after that. So I think 180 divided by 15 is 12, it is. So this would just reduce now to pi over 12. Of course, you can just punch in 15 over 180 in the fraction mode of your calculator and hit enter, and it will reduce it for you. Of course, you'd leave off the pi symbol when you push it in the calculator. Now, on part B, we're doing 350 degrees, really not any different, just a bigger angle. So recall, we've got 180 degrees in pi radians. So now, the degrees, just like on this one, I didn't do it, but the degrees cancel out. So we're going to get 350 pi over 180. Notice the zeros could cancel when I reduce it. I think that's it. I don't think there's a common factor with 35 and 18. So we just get 35 pi over 18 radians. Okay, on the last one here, number 11, we're going the other way around. We're going from radians to degrees. So we'll start off with our dimensional analysis again with the same ratio, the same factor here, but there are 180 degrees in pi radians. Now this time pi radians is going to go in the denominator because we want the radians here, because that's in radians, to cancel out. And we want our units here to be in degrees. So radians, of course, cancel. Now the other thing that would cancel here would be the pi's. So now all I'm left with is 11/12 times 180. And so if I punch it in on my calculator here, 11/12 times 180, you're going to get 165. So this will be 165, and that would be in degrees. Really important to put the degree symbol. Now, Same difference on part B here. We got 9 pi over 5 radians. And now we're going to switch it to degrees. So we know we have pi radians in 180 degrees. So again, the pi's and the radians cancel. So all we're left with is just 9/5 times 180. And so that's going to give you 324. So 324 degrees. Now, part C is a little different because notice this is a radian measure because it doesn't have the degree symbol. But it's not in terms of pi. So most of the time your radians are in terms of pi, but not always. Okay, so we got 4.02 radians. And we know there are pi radians in 180 degrees. So the radians cancel, but what happened on this one here is that the pi does not. So I'm going to multiply this out. I'm going to do 4.02 times 180. And so I get 723.6. Now the thing is we still have the pi left on the bottom. This will be in terms of degrees. Now, I'm not going to leave it like that because unlike the directions in the last problem, like on number 10, the directions here said to round to 1 decimal place if needed. So they didn't say leave it in terms of pi. So I'm going to punch in my calculator here and say 723.6 divided by, and then push my pi button. And so to 1 decimal place here, that's going to be 230.3, and then that's going to be in degrees.